Assalamu alaikum everyone. Welcome to mathematics, and now we are going to start question 6 of A levels mechanics paper code 9709, variant 42, May June 2025. So let's begin. A particle P moves in a straight line. So let's visually understand this. A particle P, let's suppose, is moving in this straight line and passes through the point A. So let's suppose this is your point A. It passes through this point at time t equals to 0. The velocity v of this particle at any time t seconds is given by this equation. That is your equation v is equals to 2t plus half to the power 3 by 2 minus 2t square for time 0 to 3 seconds. So it's somehow like this. Between 0 and 3 seconds, this time 3 seconds. So yeah, this is your equation for the velocity. Find the maximum velocity of P in this interval 0 to 3 seconds. So the thing is, first we need to understand how to find maximum velocity. Maximum velocity we know is at that point, at the point where there is maximum velocity, the acceleration must be 0 there. Okay, so we are going to use this to find our maximum velocity. So how we are going to proceed with this? We will be differentiating our velocity with respect to t. That will give you acceleration. But we don't need acceleration. Actually, we will be using then that expression. We will be putting that equals to 0 to find out the time. Okay, at which time do we have the maximum velocity? When we will substitute this time in our equation that is originally given to us, we will be able to find the maximum velocity. So let's begin. So the important thing is to know that for the maximum velocity, the acceleration at that point must be 0. So let's differentiate this. D over dt of two t plus 1 to the power 3 by 2 minus 2t square. So differentiating this will give you, first is 2t plus 1 whole power 3 by 2. So we will be using the power rule of differentiation, nx n minus 1. That means your power and the bracket as it is, and power minus 1, 3 by 2 minus 1 multiplied by the derivative of the bracket, and that would be 2. The derivative of 2t plus 1 will be 2 minus derivative of 2t square would be 4t. Now let's simplify this. This 2 is going to be cancelled out and we are left with 3 times 2t plus 1 to the power 1 over 2 minus 4t. Okay, after doing this, now put this equals to 0. As we know, acceleration must be 0 at maximum velocity. So 3 times 2t plus 1 whole power 1 by 2 minus 4t equals 0. So taking this 4t on the other side, it will become equals 4t gives you 4/3t. Now to take this out of the square root, what we can do is taking square on both sides. Squaring both sides. It will give you 2t plus 1 equals 16/9 t squared. That gives you 9 times 2t plus 1 equals 16t squared. 16t squared minus 18t minus 9 equals 0. Now going to solve this quadratic equation. We need to break the middle term and we can find it out. We need two numbers that when multiplied give you 16 times 9. What is 16 times 9? It is 144. And when added or subtracted, it should give you minus 18. Minus 144 and minus 18. So the two numbers that we will be taking would be, just let me arrange this a little bit. And this will give you two factors to be minus 24 and plus 6. So it comes out to be minus 24t plus 6t minus 9 equals 0. So taking common, 8 common, 8t common, 2t minus 3, and then we are taking 3 common here, 2t minus 3 equals 0. So it turns out to be 8t plus 3 and 2t minus 3 equals 0. This implies that t is either equals to minus 3/8 or t equals to 3/2. So obviously time cannot be negative. So this is rejected and t turns out to be 3/2 or 1.5 seconds. So this is a time at which we will be having maximum velocity. So let's substitute that. So V max will be at t equals to 1.5. So it will be 2t plus 1 3/2 minus 2t square. So we will be getting this after substituting this. Either you can substitute 0.5, 1.5. I guess it's better if you substitute 3/2 or directly do this in the calculator. You can put either 3/2 or 1.5. It's your choice. So the final answer will come out to be 3.5 meter per second. Okay, so this is your whole working for part A of question number 6. the only thing that is important here is to know that at maximum velocity, the acceleration is 0. And for that, we will solve that to find out t, and then substituting that value of t in your velocity equation to get the maximum velocity. Now head on to part B. Now part B says, starting from here, it is given that in the interval, the velocity of p is always positive. Find the distance of p from A at the instant when p is moving at this maximum velocity. So now we need to find the distance. They telling you that it is the velocity is always positive. What does it mean? The velocity always positive means that it is moving in one direction. It's not changing its direction. So that means that it is moving in the same direction. And we need to find the distance of p from A at the instant when p is moving at this maximum velocity. So that particularly means that we need to find the distance not from 0 to 3 seconds, but 0 to 1.5 second, because they are telling you to find, must be somewhere. Yeah, they are telling you to find the distance of p from A at the instant when it is moving at maximum velocity. So this was the point at t equals to 1.5 seconds, the velocity was maximum. So you need to find this distance from A to your point P. So this is the distance you need to find. So yeah, let's head on to this. Okay, taking this information for the next page. So we know that one more thing to take is this velocity. We know that we have velocity, and when we need to find the distance, that means we need to integrate it. Okay, integrating this with limits, because we also know the time during which we need the distance or displacement. So let's pursue that. So distance would be equals to integral of your velocity from 0 to 1.5 seconds, or 3/2 seconds. Okay, so let's do that. It will be equal to 0 to 1.5 integral of your velocity now. Integral of the first bracket, we can only take integral if we have the derivative of the bracket multiplied with it. So 2 must be there. So we are multiplying and dividing with 2. So one thing that we can do is take 1/2 outside and keep 2 inside. 3/2 minus, I'm distributing the integral. Okay, instead of distributing, it is better if you keep the integral 1 and just write it separately. Minus 2t squared. So integral of 2t plus 1 to the power 3/2 would be n plus 1 over n plus 1. So and 1/2, this This 2 will be vanished, but 1 by 2 will stay intact, minus 2t cube over 3, cos the integral of t square would be t to the power 3 over 3. Okay, and now the limits is 0 to 1.5. Now solving this, 3 by 2 plus 1 will give you 5 by 2. So 2 and 2 will cancel, so only we are left with 5 in the denominator. And in the numerator, we have 2t plus 1 to the power 5 over 2 minus, 2t cube over 3, 0 to 1.5. Now, substituting the limits inside, how can we substitute? First put 1.5 in this hole and then put 0 in this hole. So I am not rewriting it. In place of this t, I have to 1.5, 1.5, 0, and 0. And yeah, that's it. This becomes, instead of modulus, when you substitute in the values, they become the brackets. So the value comes out to be, you can directly do this with a calculator, and the value you are going to get would be fraction. If you keep the fraction form, you will get 79 over 20. And in the decimal form, the answer that you are going to get would be 3.95. Okay, you can take 1.5 or 3 by 2. I'll suggest you to keep it in the fraction form, 3 by 2. Okay, I have done it 1.5. So anyway, it could be right. Just substitute in the values and you will be getting your required value for the distance. So this is the distance from A till its velocity was maximum. So that's all about your question number 6, part A and B. I hope you understand this all. Thank you and Al Hafiz.